Thanks, everybody. So I know many of you were probably here to see Chris Aniszczyk, and that's not me. He looks much more handsome. But I am here to sort of talk about the same concepts that he wanted to espouse to you folks, and that is the history lesson of cloud native, sort of what has happened in the DevOps space as we've gone from classic non-virtualized hardware into this new cloud native space. As I'm sure we all realize, not everything becomes instantly cloud native, but how do we get there? How can we actually also follow this migration in our own IT environments, in our own DevOps-driven environments? If we look at the history of this, the little timeline we have here is effectively the hardware model, right? What has happened from an infrastructure perspective? We started in 2000 with the non-virtualized hardware that I think we all know of as those servers in the server room. In 2001, we started to see virtualization start to happen. Specifically virtualization both in the software layer, companies like Sun Microsystems actually starting to containerize the software within their environments, but also in the x86 space, the space that was really growing at the time, we saw virtualization starting to happen also in a software way and eventually migrate into the hardware. That migration enabled infrastructure as a service. It enabled the first real cloud functionality. Things like Amazon Web Services starting to express their compute resources as available virtual resources that anyone could consume in an on-demand fashion. And this on-demand fashion really is the cornerstone that changed how DevOps and how automation of our IT infrastructure started to shift and change. That virtualization of infrastructure, though, led to a disconnect between the developer community and the hardware community. It effectively created this DevOps environment because the developers had the ability to automate their infrastructure, but they didn't really want to manage that infrastructure. They didn't want to have to deal with the complexities of servers and operating systems, and that led to this concept of platform as a service. Let me start to obfuscate the infrastructure and just focus on my application itself. Right? And that platform as a service component then drove a number of additional resources. At this time, though, there was another big shift that was going on. Open source has been around for quite a while, since at least the late 70s, if not even earlier than that. But the open source community started to see these closed source tools, these infrastructure services like Amazon, platform services like the Cloud Foundry platform, and some of these other tools that started to exist at the time, and said, we can implement that same kind of capability but following open source paradigms, open source models, and make it a lot more flexible for everybody involved in these environments. That open source shift really was the beginnings of what we now see as cloud native. The natives of the cloud development space had been using these tools, using the tools like Amazon Web Services infrastructure to automate their way out of hard to manage hardware, and started to move into a more open source flow for those same sorts of capabilities, that disconnect between having to manage the physical infrastructure and starting to obfuscate that infrastructure. The problems that the developers had, though, were still there. There was a lot of complexity in this entire end-to-end development and operations change. The infrastructure, even though it was now effectively software managed, was still large, bulky, and still had a lot of security concerns that were related to it. And so we saw this shift towards a different packaging model, containerization as a way of simplifying what an application developer actually had to work with, what their infrastructure target looked like. They could start thinking about just the software processes that they were developing rather than the infrastructure itself. And this containerization move has really shifted, again, the concept of DevOps. Now our operations are really looking at container operations instead of application, operating system, and the entire end-to-end infrastructure operations. And that's what sort of leads us now to the today of cloud native. Now, we've learned a lot along the way. We've started with these core building blocks. We started with a server, but the server then moved from a physical box to a virtual box. From a virtual box, we then said, well, can we just not worry so much about the box and instead look at the software? This was this concept of platform services, the build pack. This defines all of the pieces I need, and I want to bundle that together. And lastly, that moved into the concept of a container. Let me containerize all of those pieces and simplify that management. So those were the building blocks. We also started to look at isolation. because I wanted to separate this. As a service provider, for example, providing these services to companies, I wanted to be able to isolate different tenants. But even within an enterprise, many of us have, I think, run into this, that each enterprise has its own internal requirements for security and segregation. So how can I provide this multi-tenancy model, but simplify the process, right? On top of that, if I can simplify the process, I can get to lighter and lighter weight representations of the underlying infrastructure. As long as I can keep that security boundary, I can get huge performance benefits, both the fact that the systems potentially run a lot faster, but I also get performance benefits in the infrastructure modeling itself. How do I actually manage these individual resources? Again, looking as the developer back into my infrastructure. There's another capability, this concept of immutability. Many enterprise applications are considered very, very delicate items that have to be babied, basically the concept of pets in an environment. I want to take care of it, I have a name for it, I love it, if it gets sick, I want to make it healthy. Versus the cloud-native approach, which said, well, if I have a way to automate my infrastructure, automate my resources, simplify the model of my infrastructure, I can start thinking about my resources not as pets, not things that I have to baby, but rather as cattle, things that I have a large herd of, and some of them may not make it. But that's okay, I can deal with that. I have to manage the larger herd rather than the individual item. All right, so that becomes another very important aspect to all of this. And lastly, we start to see this big shift away from closed source providers. Doesn't mean that there isn't closed source support, but open source infrastructure, more flexibility from an end developer, end customer's use cases, being able to map those use cases to their specific needs in an open source fashion. They can still get support from that from the classic closed source enterprise support organizations, but they have more flexibility. And that flexibility has really driven a lot of interest. That kind of leads to what Chris was actually initially here to talk about, which is the Cloud Native Computing Foundation. This was a group that was founded in 2015 with 22 members. Today, that has grown to over 120 members and will continue to grow because the needs for all these different organizations really maps very well with what the Cloud Native Computing Foundation is trying to accomplish. And that is supporting native open source cloud projects. Effectively, the best of breed tools are being mapped into this open source supported foundation model. So the software will always be there. The capabilities of that software will always be available to any customer. It's not tied to any one individual vendor. And most IT companies that I've talked to have said this is their #1 need. Flexibility in what the tools are, because they know they're going to still consume providers and support from their entire community of support organizations, but they need the flexibility to pick the right tool for the right job. CNCF has tried to bring into it all those tools that enable this cloud-native model, this pets versus cattle shift that we're seeing in the DevOps, the infrastructure to containerization shift. And obviously that was led initially by the Kubernetes environment, which is a management platform for that containerization. One of the other interesting things is that the top 6 cloud providers in the world have all also joined the CNCF. So they all also see, even though they have their own individual, effectively closed source models for these resources, they also see the open source models. And they see the importance of supporting and combining their resources in supporting this end-to-end open source flexible model for infrastructure consumption. Even companies like GitHub, one of the major source management companies, is now using containerization in production to support users that are containerizing their applications that are then deployed inside of and managed inside of GitHub. So we're seeing this huge change. In addition to all of that, I know I have a couple seconds left, but there are a lot of components that make the cloud, yeah, I'll hurry up. There are a lot of components that make up the cloud native space. The Cloud Native Computing Foundation does not have all of them under its umbrella. It has some of the key, like I said, best of class resources. And there are many, many, many more tools that all fit into this same mindset. And I think that's really the key. That's what makes something cloud native, a mindset, a way of approaching a problem and really resolving or improving our IT abilities. So there's more coming from the Cloud Native Computing Foundation. Don't forget to come back for all those other Austin events. Thank you.